Hey y'all. So today's lesson is permutations and combinations. We are still working on probability. A little vocabulary. A permutation is an arrangement in a particular order. And so order matters. That means it's very particular about first, second, third, or in the order of events. And I wrote right here factorial. If you have never heard of a factorial is the exclamation point. And that is what we are going to be using when we talk about permutations, combinations. What this means is if you have n number of items chosen R at a time. So let's say you are going to decorate your house. Let's say you're going to decorate your house and you have 10 pictures to use to decorate, but you only have enough room for 4 spots. That would be 10 items chosen 4 at a time. And so that's what that means. So the number of items and 4 at a time. We're going to be using factorial. So for a permutation, n number of items chosen R at a time. So this is the number of items you have, and this is how many you're choosing. You're going to set it up like this. NPR, n number permutations R, is equal to n factorial. So the number of items divided by n minus r factorial. So for this example, it would be 10 factorial over 10 minus 4, which is 6 factorial. And that is how you would set up this problem. So the factorial is the exclamation point. Combination is an arrangement of items in which order does not matter. Order does not matter. So let's say we have people and we need to put together a team. So we're not talking about specific positions. We just need, from a group of people, we need to pick 5 for a team. That means it doesn't matter the order, first, second, third, fourth, fifth. It just means we need 5 people. So n number of items chosen R at a time is going to be NCR. Combination. N factorial, and you see it still is n minus r factorial, except you put r factorial in the denominator. What this does is this significantly decreases the number of options we have because order doesn't matter. And then a little reminder, if you copied your notes before, this was wrong. R has to be between 0 and the number of items. If you have 10 items, then that number you're choosing, you can either choose 0 or you can choose all 10. You can't choose 11 items if you only have 10. So that is, R has to be between 0 and the number of items. Okay. Example 1. A combination lock will open with the right choice of 3 numbers from the numbers 1 through 30. How many different lock combinations are possible? So on a lock, it goes around and there's 30 choices of numbers. So our n is 30. We have 30 numbers to choose from. It says numbers don't repeat. So that's something that we want to make sure we understand, that once you choose a number, you don't repeat it for this problem. We are choosing 3 at a time because you only have 3 numbers on your lock. So we have our n and our r, and we can go ahead and put it in. 30 factorial, and then we subtract. 30 minus 3 is 27 factorial. Yes, you can type that in your calculator, but what this means, factorial, if I haven't actually explained it to you, it means you're multiplying that number times every number all the way before it until you get to 0. So 30 factorial means 30 times 29 times 28 times 27 times 26 and all the way down until you get to 1. Divided by 27 factorial, so 27 times 26 times 25 and all the way down. Hopefully you see that these numbers are going to cancel. So the only numbers we have left are those 3. So you can type in 30 times 29 times 28 and we get 24,360. Those are how many different permutations you can make. Now, I forgot to say, this is a permutation because the order is important. You have to go in a specific order for a lock combination. I'm sorry, I forgot to say this. So this is NPR, so 30P3. And I will show you how to do a factorial on your calculator if you don't know what it is. Number 2, find the number of permutations of 10 items, so that's your N, taken 6 at a time, that's your R. So again, we have 10 permutations 6. which means it's going to be 10 factorial, and then 10 minus 6 is 4 factorial. So in your calculator, you can type in 10 factorial divided by 4 factorial, and we get 151,200 permutations. That is because order matters, and it told us that it was a permutation. Okay, so let's do a few more examples. In a card game, each player is dealt 5 cards from a deck, and there's 52 cards in the deck. How many different hands are possible? So if we're talking about hands, that means how many cards do you have in your hand? Do you think order is important? Does it matter what cards you get first and what cards you get last, or does it just matter the whole group of cards? And the whole group of cards is what matters. So this is going to be a combination, because order doesn't matter. As long as you get your cards, those are your cards. So we have a total of 52, and we are getting 5 at a time. So this is going to be a combination of 52 divided by 5, and then remember you subtract. 52 minus 5 is 47 factorial. Oh, hold on. Come on. Hey. Hey. It's okay. Miss Clark. Yeah. Which one? Well, it depends on what grade level. 8th grade math, use 83s, and I think we have about 90 or 100 maybe. Yeah. They use 73. 73. We had like, last time we found we had upwards of almost 300 maybe. Maybe 3. Maybe we had more than 300, but I can't remember. I don't know. I don't remember. I wasn't here last year when we did testing, so I can't remember what they said. Okay. Miss, what I did last year was before testing, I just sent an order to Miss Ellington, and she ordered a bunch of items. Yeah. Okay. Bye. Okay, I am so sorry. Alright, so we type this into our calculator. 52 factorial divided by 5 factorial times 47 factorial, and we get, just want to double check, it's, yeah, it's, whoo, so 2 million and some change possible hands if you're dealing 5 cards from a deck of cards. How many combos, so it's telling us how many combinations of 10 items taken 6 at a time. So this is your N and this is your R. So we have 10 combinations taken 6 at a time. And just because of sake of time, I already have all the answers, and you would just type in your calculator. So the answer is 210. That means if you have 10 items and you're choosing 6 at a time, if order doesn't matter, there's 210 different possibilities of having 6 items. Okay? So number 5, a student must answer 3 out of 5 questions. So here's your R and here's your N. Essay questions on a test. In how many different ways can the student select questions? So is this a permutation or combination? Is order important? You have to decide. If a student is choosing 3 essay questions, does it matter which essay question is first, second, or third? Or just does it matter that the student chooses 3? And order does not matter. The teacher doesn't care who's first, second, or third, or which question. The teacher just wants to make sure they choose 3. So this is going to be a combination. 5 items with 3 at a time. So a combination. So that would be 5 factorial over 2 factorial, because remember you do 5 minus 3. And then you also have to put a 3 factorial in front because this is a combination. So it's n factorial, r factorial, and then minus r factorial. And I've already got the answer, and the answer is 10. So there are 10 different ways that a student could answer essay questions if there's 5 choices and they have to choose 3. From a club of 24 members, so that is your N, a president, vice president, secretary, treasurer, and historian must be elected. So there are 5 positions. That's your R. How many different ways can offices be filled? How many different ways can offices be filled? So you decide, if you are reading that question, is order important? These 5 people. Does it matter who is president, who is vice president, who is secretary, or does it just matter that there's 5 people? And order does matter for offices. It matters who's president, who's vice president. So this is a permutation, and there are 24 permutation, 5 taken at a time. So you would put this into your permutation formula, and we would come out with 5,100,480 different permutations. That's that many ways that those spots could be filled, and it is a permutation. All right. So the 25-member class, so there is our N, is electing a president, vice president, and secretary. So 3. Megan would like to be president, John for vice president, and Emma for secretary. If the offices are filled at random, beginning with the president, what is the probability they are selected? So what is the probability that these 3 are selected? And you see the word probability, so underline that. We have to decide, is order important? And the answer is yes. President, vice president, secretary, it matters in that order. They want to be the president, vice president, secretary. So this is a permutation. 25 permutation 3. When you work out 25 permutation 3, you end up getting 13,800 ways for this order to happen. Megan, John, and Emma. But the question asks for probability, and so the probability is what is the chance of that happening out of the total outcomes? Well, we know that there are 13,800 total chances, like possibilities. So the probability would be 1 out of 13,800. So just make sure you understand when the question's asking you for how many ways or what's the probability. That's going to change the way you work it. 25 members, so there's your N. Class selecting members for the dance committee, so it's just members. So order is probably not going to be important. Denver, Jaden, and William would like to be on the committee, so our R is 3. What's the probability that all 3 would be selected? Does it give a specific order, president, vice president, secretary? It does not. So this is going to be a combination because order does not matter. Denver, Jaden, and William just want to be on the dance committee. It's kind of funny. Denver, Jaden, and William. So 25 combination, and we're picking 3. 25 combination 3, and that answer is 2,300. There are 2,300 different ways this committee would be formed, and out of that, the probability that these 3 boys would be on the committee is 1 out of 2,300. So when it asks for probability, don't forget to give it as a probability, a fraction out of the total number of outcomes.